So hello, good afternoon. Welcome, glad to be here at MLDS 2020. There's a buzz around MLDS and Sheldon Cooper comes to mind, and I can think of Bazinga when I think of buzz. So quick introductions. My name is Vinay Mony. I'm the principal decision scientist at Ugam. And for company, I have my colleague Arpita, who leads the cognitive computing systems at Ugam. Oh, I need a clicker, I think. The clicker. So while we have introduced ourselves for folks who are not familiar with Ugam solutions, oops. Yeah. So Ugam's a data analytics company. We are across multiple offices, 4 in the US, one each in US, in UK and Australia, and we are across 3 cities in India, Mumbai, Bangalore, and Coimbatore. We're about 2,000 employees. We've been around for 20 years with a good history of growth. And recently, we've joined the Merkle family, which is a big US firm in the marketing performance area. A lot of our focus you'll see is retail. That's where our strength is. We also work in verticals like market research, consulting, and high tech. And you'll see a lot, but today we will see a lot of examples in depth in the retail space. So that's a quick introduction about the company. So what are we talking about today? This is a scenario that we've all probably face on a day-to-day basis. Your nephew, his birthday is up in the next 2 days. You promised him a superhero. It's okay if it's your nephew, but if it happens to be your better half, spouse, girlfriend, boyfriend, you're probably in a bigger soup. So this is a safer scenario. You're in Bangalore. Over the next 2 days, there's no way you're going to get to a store. Right? So what comes to the rescue? We have e-commerce and subscription services like Amazon Prime, instant gratification at your fingertips. But how do you really get to that action hero? Right? What is the typical consumer experience? You would go to a search engine, typically, let's say, a Google or a Bing, and discover your product. Or if you as a retailer have figured out how to break the clutter, you would have your consumers go directly to your website. This consumer experience is what Google has branded as ZMOT, or the zeroth moment of truth. Obviously, this is a little self-fulfilling for Google, but a lot of this is probably true to a large extent. This consumer experience, and if you can capture that, goes a long way in how you capture share in e-commerce. So once you've gone through your search or your organic visit, and if the consumer doesn't happen to convert, then you get a store visit. And then it all depends on what consumer experience you have and where you convert. So there is a big battle for gaining this ZMOT, right? And a lot of companies are investing a lot of processes and technology to capture the ZMOT battle. And a lot of this is driven by AI. But at Ugam, we believe that it's not AI as we conventionally see it and commonly hear. We also want to look at it from an augmented intelligence perspective. We'll talk about this a little more, but essentially what we are trying to say here is that it's more than just algorithms. There are a whole lot of systems and processes that need to come into place, and the human angle cannot be ignored. Right? We'll get into details of that. And what drives a lot of this machine-led world? We call it JARVIS, and for folks who are fans of Marvel, yes, our inspiration is Iron Man. So JARVIS is our platform for cognitive computing that helps us parse through a lot of unstructured data and solve problems like some of what we're going to talk about today. What also helps us is some of the data that we capture on product intelligence that acts as raw material for our machines. So what we're going to talk about today are really in that e-commerce space, two sort of core deep areas of what we call e-commerce product setup and product matching. And what algorithms go into that, how do we build a learning system, and what are our learnings based on what we've implemented. Right? So Arpita and me will sort of tango with each other to take you through these cases. Arpita?
Hi, now you can hear me? All right. So I was listening to the news this morning, and the biggest news piece today is that Trump's impeachment trial is going to start. And, Trump is such a character, you can't help but laugh. And some of his ideas are a marvel in itself. So I started thinking back to a particular news piece that had come a few months back, in which they had started talking about Trump and how he had taken it into his head that he wanted to buy the entire island of Greenland. And as crazy as that sounds, I'm pretty sure that at that point, Trump might have thought that it was as easy as just let's open up Amazon and start, searching for Greenland. Now, the fact is that nowadays it looks like most products are available, apart from Greenland, but most products are available for us to buy at a moment's notice in case we can't get to the mall or if we're feeling too lazy. So at a moment's notice, we can get things online, right? Most products are available. And we've all seen product pages like this, right? Now, have you ever thought about the little bits and pieces that sort of come together to give you the information that you need to make that product purchase? And what we're going to do is at Ugam, we help our clients to set up such product pages with the help of machines to help them to increase their conversion from product consideration all the way to product sales for their customers, right? So we'll take you through how some of the aspects where machines help in setting this up. Uh, so up here, usually you see a lot of product categories and subcategories, right? So in any product page or when you go to a retailer's website, you'll see a bunch of product categories and subcategories. And that's what we call the product taxonomy. Now, products are usually categorized under some sort of taxonomy. And the decision that which product will go under which taxonomy helps to increase the findability of the product. So if I'm searching for a Marvel character, can I actually go and find it? Is my product available for me? Right? So there's a lot of science that goes into deciding under which category a product should go. Apart from this, there's also the product description. We've all seen the description of the product. Some retailers have very creative descriptions, and some not so much. But if you think about it, this product description that has all the information that needs to be creative and attractive, some of these retail giants, online retail giants, they have to create these for their millions and billions of products. Like Amazon, for example, has 3 billion SKUs. And they have to actually write this out. So imagine, having an army of people sitting and writing this out. And it's close to impossible, which is again where machines come in. So we'll talk a little bit about that. And then lastly, There's the table of very useful specifications, product specifications or attributes that are usually at the right after the description part of a website, of a product page. And these are the hard specs that help you to actually get the information of the product, helps you to compare between two products and helps you to make that final purchase, right? So let's start with the last one first. So product attribution. Now, in order to get all those bits and pieces of information that makes up that table, typically a person would have to go to a large number of sources and extract the information. The information could be in, for example, in packaging material, right? Or the information could come in the image of the product, or maybe in some text material, maybe suppliers have given manuals, or suppliers have given descriptions, manufacturer descriptions, specs sheets. And then also we could just go and Google the product, right? Some other retailer might have set it up, or in some way we can get information about that product online. So that's a very useful way of getting information. But the problem is that all of these are different formats of information, right? For example, the first one might be a PDF or a PNG. The next one might be a JPG. The next one might be just, again, text, just plain text. And so to extract information from all of these, first of all, we would need machines to do it, but we need multiple different algorithms and different techniques to do it, right? And so we use a combination of these, and I'll go into each of them in some detail. So here is a typical situation where we are getting the packaging label. Now, packaging labels come to us in terms of, art copy. They might be, again, like I said, a JPG or a PNG file or even a PDF file. They might be scanned and sent to us. And what we typically do is we use OCR techniques to extract the text, all the text material. So as you can see over here, the age is given over here. There might be some information over here, and we extract that text. But since it's a picture, we are extracting the text using OCR, right? Now, OCR is used, we extract that text, and then from that text, we have to actually figure out what is the attribute or what is the value of information that we can get from this to put into that specs table. Next, we might also need to extract information from the actual product image, right? Sometimes it's not all written down. You might have to actually get out the information from the image. For this, we use pre-trained neural net models. And then what we do with these so the neural net models like, Inception V3, we use transfer learning on top of that model for the particular category that we are working with, right? And so in this category, if you're trying to say that these images, we need to extract color from these images, then we would do a transfer learning model on top of a pre-trained neural net model to get that particular attribute. And then lastly, a lot of the information comes to us in terms of text, right? Text might be things that we have mined from the internet, or it might be supplier information that is given to us. A whole another ballgame is if we get PDF files that the suppliers give, like catalogs or specs sheets. And the PDF file sometimes has, it has its own problems in terms of extracting information from PDFs. There are lots of packages available like PDF Miner, PDF to text. Or, if there are tables, then you might use Tabula or wrappers that have been built around Tabula. But the fact remains that we end up getting a lot of text type of information as well. And from this text, we then start mining attributes. So you're basically using dictionaries to try to get at what are the attributes that are hidden in all this text, right? So usually you get a whole text string and you try to pick out the attributes. Now, these dictionaries are also created in an automated way. So we have built algorithms to create automated dictionaries, and the dictionaries are category specific. So we have this whole database of dictionaries, and as we work on new categories, it keeps adding to that. The automated dictionaries are validated by category experts. As Vinay has pointed out, you can't just do AI in isolation. A lot of times you do have to apply a human validation layer, right? So once the dictionaries are validated by human experts, we then go in and feed that back into our dictionary database or the attribute database, so that our next round of mining of attributes gets more efficient, and we are then able to get better results. So in doing all this, of course, we've been doing this over several years now, and we've got some learnings. Now, OCR techniques typically, they were rudimentary initially. Now they've improved a whole lot more. But we still find some problems if the text is very small, or if the picture that you're trying to extract the text from is fuzzy or hazy, right? So that's one thing that we really need, good resolution pictures in order to work with OCR. The other problem where OCR fails is also similar to where PDF extraction fails, is if you have two blocks of paragraphs, right next to each other, two blocks of text, and they're separate blocks, but they're so close together in the PDF or in the picture that when it's reading, when the algorithm is trying to extract it, it extracts it as a single block. And so then again, the whole information is garbled, and we have to figure out how to work with that. So that's one of the learnings. The other learning is in terms of the image-based attributes. So we found that, trying to build neural net models from scratch for images. The architecture is out there, there's a lot of, convolutional network models, and the architecture is there in case we want to build it. However, the massive amounts of images and the massive amount of compute power that you need in order to build it from scratch is so immense, and we found it much easier to use pre-trained models that are out there and then to build transfer learning layers on top of that. So just wanted to share some of that. We'll go on to product descriptions now. Now, so we've done with the attribute tables. We want to write the description based on that. Description writing is a difficult thing, right? It's a weird mix of creativity and rigor, right? You want that description to be attractive, so that when you're searching for that product, or when the customers come to search for the product, they get attracted to it, they feel like buying it. So in that sense, it's sort of like writing advertising copy, where you just want to grab the attention of the customer. But at the end of the day, it is a product description, and it's on a product page, and the idea of that is to give information about the product. So you want a whole bunch of information to be infused into that. It's not as simple as just writing one tagline for this thing. You want it to be attractive, but at the same time have information. On top of that, we have to take care of a lot of other types of considerations. For example, some retailers may have specifications in how they want their product descriptions written. Like sometimes we get specifications, right? We want a single line, and then all the attributes we want as features, in bullet points. Or sometimes we might get a requirement where the retailer wants us all to have all their numerical dimensions and stuff in a particular metric, maybe only in the metric system, or maybe only in the feet and FPS system. So we need to take care of all of that also while writing. And then another consideration that we have to often think about is SEO, or search engine optimization, right? The words that are used in the description are used by search engines to help find the product, right? And you want your product to be found, otherwise the sale is not going to happen. So we have a list of keywords that we need to infuse into the description as well. So all of this needs to get taken care of when you're writing a description. And can you imagine, like if we had to have people whom we are training to do that, the amount of training that it would take and the amount of time it would take is quite mind-boggling. So we have done a couple of different solutions. We created a couple of different solutions for this. The first is a human-led, machine-driven solution. And what I mean by that is we have a number of some very experienced product description writers and editors, right? And they have over time created their own set of descriptions that have been, approved and authorized by the retailer who they are working with. What we do is we take those descriptions, and for those descriptions, we convert them into templates. Now, how do we do that? Basically, we have algorithms that look through the descriptions and recognize what are the attributes in those descriptions, weed them out, and replace those attributes with attribute tags. Right? And I don't know, you won't be able to see it here, this is too small, but this is the type of a template that gets created from an existing description. Now, these templates are stored in a template database. And then the next time a new product comes for that retailer or for that product category, the algorithm searches, first we do the step of taking out all the attributes, and then based on those attributes, the algorithm searches the template database to find the right template to use, given that you have all those attributes. So it's sort of, there's an intelligent algorithm technique that basically picks out the right algorithm. It then fuses or infuses all the attributes into the right where the placeholders are and creates an entire description. So, so here we have the system in our user interface which has all the attributes. The algorithm is searching for the right template to use, and it has then infused the right attributes in the right places to create a unique description each time, right? And so that is our human-led, machine-driven solution. The second thing, so this works pretty well in a place where we have a lot of descriptions available or we have a lot of experience, right? But what if we have a new retailer we are working with whom we've not worked with before, or a new category? So we are working with a retailer, but they've given us a new category to write descriptions for. So we don't have that level of templates already ready. In that case, what we found useful is to use natural language generation, right? And here we have, we use natural language generation to do two different types of things. One is, when the writer has started writing out their description, we use natural language generation to autocomplete. Autocomplete is, sort of like Google, where, you start typing out your search string and Google has a whole list of suggestions of what you might be searching for. So we do the same type of thing where we are suggesting to the writer what they might want to write next. Or we can also use natural language generation to actually generate out the entire description, right? Now, we've experimented with two different types of models. One is a statistical model, Markov chain models. These are based on conditional probabilities, and they use the n-gram structure. They're trained on a whole lot of past descriptions, maybe with the same retailer or in that same category. So they sort of know that if, and then when the writer starts writing out the description, it predicts that, if these are the last 3 words or the last 4 words, depending on how your n-gram is structured, if these are the last 3 or 4 words, what is the probability that the next word is going to be XYZ, right? So that's how it keeps predicting out the next word. And so it's a conditional probability model. One downside of this is if your training data set is not big, and if it has never seen the words that you have started typing out, then it will, by virtue of the method itself, it will not be able to predict out the next word. So we found better success with neural net models. These are the typical sequence-to-sequence, decoder encoder architecture. There are a lot of models, pre-trained models again, out there like BERT or GPT-2. And what we do is we start off with those, and then again we have a transfer learning layer on top of them, which are trained on our on a particular category, or if you're writing for a particular retailer, for that particular retailer, so that we are basically customizing that model to our context, right? So this is an interface that our Ugam's JARVIS system has. Again, over here you'll see, the writer has started writing out some description, and this is the type of suggestions that have come based on the data that the model has been trained on. And here on the right side, for the same thing, there are a number of suggestions of how you could fill out your entire description. So it can even write out complete descriptions for you. So what we have learned in this process, right? The statistical Markov chain types of models are pretty easy to understand, right? I mean, intuitively you can get what is conditional probability, knowing very basic stats. But having said that, they get very computationally intensive. And so it's fine if you're just trying to complete the next word or the next 2, 3 words, but if you're trying to write out full sentences or the entire description, then it gets pretty difficult to, it gets computationally very intensive. Next, as I said in the starting, there are times when you want specific attributes or specific keywords to be included in your description. And this particular method of using natural language generation doesn't always guarantee that the words that you want will go in, right? Because it's either a neural net or a conditional probability. It will not always have the words that you require. And here again, that concept of augmented systems that Vinay was talking about, that comes in as well, right? Where you have human validation on top of generated description, so that the person doesn't need that entire creative bend of mind, but can at least infuse in words the keywords as required. We are also experimenting a little bit with trying to get the natural language generation techniques to generate templates instead of the descriptions, so that the templates can then be infused with the required keywords. So what we have found, another learning that we had was that these types of solutions, when we are building it, they're best done in partnership with the practitioners themselves. So we worked very closely with the writers and the editors to figure out how to structure this entire solution. And in fact, we have Golden Pyramid Awards in our annual event in our company at Ugam, and in that there are awards given out for a variety of different categories. 2 or 3 of the very prized categories are innovation and creativity. And so here, for this particular effort, we got the a team innovation award. So because the idea was that it was built as a team, in partnership with the practitioners. So I'm going to take you through, so both of these things in action. This is a case study of a national retail chain that we worked with. So they were a retail chain that had many stores. They were a chain of stores, but they had very sparse online presence. And then, as all of us have found, and many retailers have found, their customers started wanting to shop online. And they had loyal customers, but their loyal customers couldn't find the products that are in the store on the website, right? And so they started getting a lot of flack for that. And, obviously lost sales. So they wanted to move all their products onboard their products on their website, right, on their retail website. Now, their problem was that they had no digital content experience themselves. And on top of that, many of their products, 70% of their products were private label products. And what that means is, it is difficult, if you have a private label product, it is difficult to go to the internet or to a competitor website and search for the product and the product attributes and stuff. All that information is not readily available. Also, for private label products, supplier spec sheets may not be as easily available or as customized as you might like it. So it's much more difficult to create attributes and descriptions for such situations. So now they came to us, and we took in, all their different sources of information, like packaging, labels, and, whatever little bit of descriptions that the suppliers had given, plus the supplier images. And from that, we mined whatever attributes that were available, and we created attribute spec sheets for them. We also had natural language generation writing out the descriptions for the products in an algorithmic way. And we were able to, in the space of a year, we were able to onboard 99% of their retail products. And it's estimated to have saved them like $7 million in lost sales. So now that's basically, I talked to you all about attribute specs, the attribute tables, as well as product descriptions. I thought Vinay would take you through how machines can help with the first thing that I talked about, which is product taxonomy. Here you go.
Yeah, well, I'll let Arpita catch a breath. So findability is key, right? If you don't ultimately find your products the customer is not going to either experience your platform or leave alone buy. So so imagine, go back to our superhero theme, and you're trying to find the gift for your nephew, right? These could be candidate gifts. And looking at these products, what could be search keywords that you might type? Would you call them Avengers pencil box? Or would you say Marvel stationery? Or would you say superhero toys, right? All three could not be wrong. It really depends on what your state of mind is and what you're looking for, right? So that's the challenge in findability. How can you make your product categorization intuitive and close to the consumer and what he's thinking, he or she is thinking? And what complicates matters is that today there is no standard amongst e-commerce platforms in terms of this taxonomy and classification, right? So one retailer could call the same product under creative toys. The other could well call it, stationery, office products, and pencil case, right? So at least for today, there is no standardization amongst platforms. So this really, if you think of it, is a classification problem. Essentially, what you're trying to do is, given products and product attributes, what category is a product likely to fall and is most intuitive for a consumer. So here is an example where we are using an unsupervised method where we take product names and descriptions, extract their attributes using methods like Arpita talked about, and then being able to use clustering techniques to create intuitive groups that these products can fall into, right? So in this case, we were doing this for a home improvement retailer. The category was gloves. So you can see that it sort of used the attributes and put it into groups like leather gloves, chemical gloves, dexterity gloves. So this acts as a validation for an existing classification or taxonomy. So when you run a product through this clustering, if you find something that's non-intuitive and falls in the wrong category, there is an opportunity to change that, right? So this is an unsupervised way of going through the product classification. The other approach could be when you have an existing classification and you know the taxonomy, you know that a certain product belongs to a certain category, right? So you already have some label data, right? So here you can use the supervised approach and create a model which predicts really what is the likelihood of a product falling into a certain category based on attributes, right? So as you can see in that spider chart, you would get probabilities for each category, and then based on the probability, you can decide which category should the product fall into. This sort of approach works well when you have new products, right? And you really don't know, or not sure which class it could fall under, right? So when you have label data and you can train a model, this classification works well. What can get more complicated, and this is often the case, is that when you're trying to figure out the category that a product needs to fall under, a lot of retailers say, can you be more prescriptive around what particular leaf node does each product fall under, right? So should it be, like in this case, toys and hobbies and directly helicopter, or should it follow this flow of models and kits, military aircraft, right? So what does this drive? As a consumer, when you're going to a website and you go through the left navigation pane and you try to choose your product, do you lose your way trying to find the product, or is it as intuitive as a consumer would want, right? So if you want the leaf node for each of these categories, you can use in this case, we used a hierarchical clustering approach, which really gives sort of a hierarchy and tree for where each product falls under, and you'll see in the end nodes, each SKU falling under each of those leaf nodes. So these are three sort of different ways of how we can use algorithms to classify products. And just to go back to the theme of a lot of these applications, a lot of these were really, cognitive intensive activities earlier, and there used to be a whole army of people sort of doing just this, right? And this is where a lot of the algorithms are now changing the way we do this and helping e-commerce scale. So what have we learned? There can be genuinely a lot of crossover products. What does that mean? That product could fall well under toys, or it could fall under stationaries too, and both could be intuitive, right? So there are sort of multi-class and multi-label approaches that we are trying to use that allow for products to sit easily in two categories. The other complication could be product positioning, right? Very intuitively, in this case, for example, I could use a toothpaste product in personal hygiene, right? But if a brand decides that it is coming up with an Ayurvedic toothpaste and I'd rather be it in oral hygiene or healthcare, right? That could throw my algorithm off. So what could help here is better attribute mining, like Arpita talked about. The more data you have on attributes and the more precisely you're able to mine what that product is meant to be, that could help mitigate some of these phenomena. I'll let Arpita take over a little bit to talk about an interesting problem we are solving around product matching and what we're doing there.
So what is product matching and why does it matter, right? A situation that I came across, hopefully this is a joke to you all and not reality, but the fact of the matter is that customers are always looking for deals, right? We always want to get the best deal, looking for better deals. And online customers have just taken it to another level. You'd never buy, one thing without checking whether it's available in another website at a better price, a better variant, and so on. So what does it mean for the retailers, right? Since we work with the retailers, it's very important. It's not just enough to set up that product page and to make sure your categorization is correct and your descriptions are fine, but it's also very important to stay competitive. So it's all sort of comes together for the retailer in terms of making that final sale, right? So retailers need to be very competitive. And for example, going back to the Marvel example, if that customer who's looking for that gift for their nephew comes to my website, I have a product, but I don't have the right action character that she's looking for. Maybe she's looking for Iron Man and I have Captain America, or maybe she's looking for Captain America and I have Iron Man. Wrong product. Or maybe I have the right product, but it's just the wrong price, right? It's priced higher than my competitor and I lose the sale. So I wouldn't want something like that. So part of what retailers or e-commerce retailers have to do is competitive monitoring or competitive intelligence. And there are three or four types of things that they need to think about, right? In order to stay competitive, one of the questions they need to ask is, do I have the right product? And that's what we call assortment intelligence. Another thing is, do I have the right price? Are my products priced correctly, or am I giving the right promotions at the right time? That's what comes in the whole world of price intelligence. And then there are other things like, do I have the right brands? Do I have the right distribution of brands? Do we have the right digital share of shelf? And so on, right? Now, if you think about it, all of these require the retailer to compare their products with the competitors' products. And it might be one competitor, multiple competitors, but at the very base of it, you need to be able to know whether the product that I have here is the same as the product that they have there, right? And that's what product matching comes to. And typically what happens is, within a particular category, we end up looking, the retailer would end up looking at each of their products and trying to find whether each product has a match, either an exact match or a similar match. So for example, a similar match might be, hey, he has the same action figure, but the action figure doesn't have the same accessories, right? So it's exactly the same product, same brand, everything, but the accessories are different or something like that. So that's product matching. And if you think about trying to actually do that in a manual, in a human way, the human would actually have to take all the data from the retailer and the competitor, then one by one look at all the attributes and make sure that that is matching, the title is matching, is it the same image? And it's just very, very time consuming. So for retailers where, machine learning has not entered their world, they take a lot of time doing this, and because it takes a lot of time, they don't do it very often. So, they stay competitive once a month or once in a quarter, and that's as far as they get, right? And then, when you think about, hey, I have this match, then you have to look at, is it the exact match? Is it a similar match? It's just quite crazy. So what we have done in this case is we started using a couple of different methodologies. So first we look at all the text information. So I talked about the title or the description or the attributes. So we look at all the information that we have created. When we create the product page, we've created a bunch of information. Now we take all that information from the retailer's products and from the competitor's products, and we try to do a text matching. And I'll go into how that works. And then lately we've also developed the ability to look at the image of the retailer's product and the image of the competitor's product and try to match those as well, right? So, and then of course, trying to harness the power of both in ensemble models or in composite models, right? Now, in text matching, so initially when we started this, in text matching, what we used to do is we used to start off with the attribution. So as I told you, we extract the attributes from the retailer's products, right? And we would have some very key attributes that have to be matched before we can call something a product match. And in this case, for example, I've just taken the example of rings, but here we've said that these 5 attributes are the important attributes, and then we would do an attribute to attribute match, right? So we have attribute pairs between each of the retailer's products and all of the competitor products, and you're sort of looking at that. Now, as you can imagine, let's say I have one retailer product and 50 competitor products, and I'm trying to find the match. And let's say I have 5 attributes, that's like 250 matches, right? But let's say there's a particular category, a product category like, like a laptop, which has like 10 or 15 attributes. That same thing, it's multiplicatively more, if that's a word, right? And so it gets computationally intensive to try to do attribute to attribute matches. Instead of doing 50 matches, you're basically doing 50 into whatever number of attributes that you're trying to do. So we developed an NLP methodology for this, where we start off by selecting what are the features. So even in the earlier case, we had all these attributes. Here we might choose separate attributes, or we might just throw in the entire description as a particular feature, right? And so we select all the features, we sort of create a string, a text string out of that. Then we use feature vectorization. So for those of you who are familiar with NLP techniques, you could use a number of different vectorization formats. You could either use simple TF, IDF, or you could use, something like glove embedding. And once you get the vectors of the text for the retailer product and for the competitor product, so for each of the retailer and competitor products, you're then trying to look at what is the similarity between the retailer product and each of the competitor products, right? So again, if you have one retailer product and 50 competitor products, you're looking at 50 similarities, right? Now, similarity measures also vary. You could do simple stuff like cosine similarity, which works pretty well. Or you could go a little further and go into, methodologies that have been developed like Siamese networks and so on. Those are neural net models, so they keep improving over time, and they also take the context of the words into account. So they work a little better, though they take more computing power. And once you get the similarity between the retailer product vector and the competitor product vector, you would then sort the competitor products and say, okay, so this is the best match. So now this is an interface, again, from our JARVIS IQ system. I took the same example of rings to sort of say that, okay, so these are all the matches that have been thrown up. So the first one is the retailer product, and these are the matches that have been thrown up. And what we typically do is, if it's a pretty high score, so over here the scores, or the probability scores are put over here. So if it's a pretty high score, the system automatically takes it as a match and just goes on with it. And if it's a really low score, also the system sort of rejects it. But it's the in-between cases that we offer to our human validators to actually check whether it is a match or not, right? So even though these matches have been done based on the text, we also provide the images to them so that they can visually see what is a good match and what is not. Now,
I just want to spend a minute on this tool and why it's important. This is what we call an annotation tool. So when Arpita talks about a human validation, this is what ultimately drives the feedback loop when we talk about learning. And we'll talk about a learning system at the end, but we find this as an important component in our whole system of how the algorithms learn.
Right. And
if you're wondering why we went from Marvel characters to earrings, it was intentional. If you can match earrings, you can match any product.
So now what have we learned in doing this type of text matching or using text matching, right? A few things that we found is that text matching works well in most cases, but for example, if you remember the earlier methodology we had of looking at attribute to attribute pairs, over there we could actually specify that one attribute is more important than the other attribute. So for example, in the case of the Marvel figure, for the person looking for a particular action figure, the character of the action figure, whether it's Iron Man or Captain America, for example, might be much more important than what are the accessories that the product has, right? So over there, we could actually give more importance to the weightage when we are matching two products. But if you're using vectors for text vectorization, and then you're trying to use text NLP matching for that, it is very difficult to say that one particular attribute or one particular word is more important than the other word, right? So in that sense, we need to come up with creative ways of taking into account attribute matching as well as text matching. The other downside is, having numerical attributes. When you do text matching, or when you're looking at similarity with text, there's a certain amount of information that you get with the number itself, which text vectors don't recognize, right? They don't treat it as a number. So for example, let's say the retailer has an 80-page notebook, right? Now the competitor has exactly the same notebook, in all other ways, like it's a square line book and it's the same brand and all of that. But the competitor has two types. One is a 100-page notebook and one is a 500-page notebook. Now typically when a human would be looking at it, they would immediately know that the 100-page notebook is a closer match to the 80-page notebook than the 500-page notebook, right? But in terms of text vectorizing a text, it will not know that. So that numerical information is lost. So over here again, we use composite measures of text and numerical similarity scores to try to get the information from the numerical attributes. Lastly, the reason we chose the rings was to actually highlight a particular problem, which is that where you have hard attributes, which are very clear, and there is no confusion around it, like specs of an electronic item or a laptop or a phone or something like that, where the attributes are very clear. In those cases, this type of text matching works very well. However, in soft categories like fashion, where the same top, like if I have a red or a maroon top, and one retailer will try to describe it as burgundy, and another retailer will try to describe it as wine red, when you have that type of thing going on, then the text matching algorithm sort of gives up and says you only manage, right? So in these types of situations, we find that text matching doesn't work well. So here is an example of a shoe. This on the left-hand side is the retailer's product. And the text matching algorithm threw out these as options. And with a glance, you can see that they're not the same. But there are reasons why it picked it up. It has some similar words, Lauren and mules and leather, and some stuff is similar. So that's how it picked it up. But when we use image-based matching, we find that this on the right hand side is what the image algorithm threw out, and it was able to immediately highlight the first match that it highlighted was the exact match, right? And so in certain categories, image matching works a whole lot better, right? Now, again, similar to the earlier interface that I showed you, this is again an interface that is provided for image matching on our Ugam's JARVIS system. And this, again, is thrown up for those borderline cases. It is thrown up for human validation, and the human validation is sent back in a feedback loop to improve the models further, right? So that is a theme that we use across. So in image matching, what we are doing is we are using pre-trained neural net models that are available for computer vision, like ResNet, there's Retina Next. There are a whole lot of options that can be used. And these these are typical CNN models where convolution is used to extract the visual features from the images. And then you have sort of a feature vector for the retailer's image and the competitor's image. And these image vectors are compared. And again, you could use a similarity, some sort of similarity measure to see which works, which is a closer match, right? And so again, that's the type of matches that we would do. So what we have learned in this, surprisingly, I'll tell you, I was surprised to find that, just straight off using pre-trained models that are available, like we used a ResNet 50 model that was available. Just using that for vectorization and not doing any transfer learning worked pretty well for us. And the reason for this is those models have been trained using a very wide variety, a very wide range of images, right? And so they work for whatever category of images that we are working on. So they work pretty well. Also, in this particular case, we are not really trying to classify what is that image, but we are trying to see whether two images are similar. And so in that sense, as long as the vectors work in the same way, it tends to work. And then in certain categories where we need higher accuracy than what the model is giving us, or where we have images already, we use a transfer learning mechanism to train it on the specific images that we already have. And of course, as you all know, if you're working with neural net models, GPU compute power is an absolute must. That's what makes it faster. Otherwise, it just takes too long a time.
Yeah, so in summary, I think if there was one message that we wanted to give, and you'd have heard a lot of augmented and human validation terms being used, I think we strongly believe that today ML and machine learning is probably used pretty loosely, right? And there's a lot of focus just on the second layer of algorithms, right? But we believe you really need to get a lot of processes and technologies in place to really get the learning flowing. So we need the data ingestion, we need the monitoring, we need the validation, and finally we need the consumption to all flow in together that enables the feedback loop, right? And this is what we try to do in trying to put together any learning system. And you would have seen some of that examples when we talked about the annotation tool, when we talked about how we want to validate along with practitioners. So that's really one big message. And finally, to connect with why we called the theme as where's my superhero? Obviously, hopefully the nephew got his right gift. But the analogy really is with AI being the superhero that we think it is, right? Is it really today? That's a question mark. But to think of Spidey, with great power comes great responsibility. I think we have the power to create strong AI systems, so it is our responsibility to enable AI to achieve what its potential is. So thank you, everybody, and we're open to questions.
Description is universal, but the product is having different combination of colors and all. Product description is universal, but the drop down is having all color, different color options or size option and all those things. So when you might be writing, when you are searching for that shoe probably or that cloth, you might, how you take care of that drop down boxes in your description?
Yeah, there are some data validation methods that we can apply. Arpita, you might want to talk about that.
So we basically take all of that into consideration, like what is in the description as well as what is in the, what we call the specification table or the drop downs. And our algorithms are trained to look at the dictionary. So I mentioned that we have attribute dictionaries. So the attribute dictionaries mine through all that information to pick out what are the correct attributes, right? There may be times where there's something written there and something written below and they might conflict. They might, in that case, they might throw up both of them and highlight it in, hey, this needs validation. Right? If it is a conflicting thing, if it is matching, then it may not do that. So that's how the algorithms
and
deal with
a lot of times the conflict also is with different sources. So you want to validate whether you're getting the right source. So there is a validation layer where we might get data from the same data from different sources, and if we find discrepancy, then we sort of create a tiebreaker. So there needs to be a data validation layer when we are mining those attributes.
I have one question. What I can suggest is, she told that the text analytics did not give good results. What happens is, any NLP package comes with a default dictionary. Most of the time it is a Stanford dictionary or what is called the centiword. What you do, you extract the keywords. Either we have two methods of extraction. One is called the keyword, chi-square keyword extraction. Other one is the network based. You extract, you get some type of words where the dictionary gives equal weightages. What you do, you go to the dictionary, edit that, give a higher weightage for that, then it should work. Definitely it should work.
I will try that. Thank you.
I have a question. So you said you'd be clustering based on categories, right? So if
Clustering
over time,
based on product attributes to get categories.
okay,
To
so
get
if,
where the product should fall.
so if you have a new category coming over time, so your new product or the products that are already existing would probably never go to that new category because you haven't trained your model based on the new category at all.
So that's where unsupervised clustering methodologies come into play, right? So we would first look at, so either you already have a
So
categorization
how
you're trying
often
to
would you retrain the model to know that there is a new category based on time?
There's a little bit of domain knowledge that comes in over there. In a very established retailer, you don't need to retrain very often. So if you're working with Amazon, for example, they already have a very wide range of categories. But for example, if you're working with a very specific home improvements retailer, for example, and they have their categories, but they're expanding into a new category, right? They would tell you that we are expanding into this new category, we don't have the setup, and then we would help them to create the clusters or create the categorization around it. Does that make sense? Yeah, so then you would go back for that new category, then we would suggest to them that this is the subcategories that you require within this new domain that you're in.
And to answer the question of when, that's where we think that the monitoring layer is important, because as soon as you realize that you're getting misclassifications and some of these products don't fall in the right bucket, some of that could also use sort of business metrics. So if you're finding the search volume for some products going down, that could also be a trigger for you to think of should you rerun your algorithm or recalibrate.
You guys used Jensen models to get the similarity, probably, no? Like Glow or Word2Vec, whatever. So if you guys will use fast text, because it breaks the word, and like if we are dealing with products, it is possible that we come up with vague names as well. So if, like what I feel is if fast text is used instead of Glow or Word2Vec, it might give us better results in such cases.
Thanks for the suggestion. I'll look into it. Might work.
So let me make sure I understood your question right. So you're saying the attribute is identified correctly, and you want the customer to sort of make sure he reads that. Yeah. Yeah. So that's a tricky trade-off because you would want to do that because you want to follow SEO guidelines, right? So there is something called keyword stuffing, if you all know about SEO. So Google prevents in a paragraph of 300 words, if a word appears more than 5 times, that you get penalized for keyword stuffing. So you want to be careful of that trade-off. But what we could do is, to answer your question, is sort of put a limit or a calibration on the frequency of that word occurrence in the passage, right? But like I said, it should be in a boundary and not way off. So that's one way I can think of highlighting. If your theme was more around sort of intuitive thing, making it bold, italic, I think that's a pretty easy sort of layer to put on in a passage.